Okay, polynomial functions. So this whole unit is about polynomial functions, and we're going to start off with what the graphs of polynomial functions look like. All right, so first, a polynomial function, they're what we've been working with. So like x squared plus 3x minus 4. That's a polynomial function. So it's just saying that a sub n, so the numbers in front of your x's cannot be 0, and n always has to be a positive integer. So no negative exponents. A sub n is the leading coefficient. And then polynomial functions are smooth, wow, I can't talk, smooth curves with no breaks or gaps, and are continuous for all real numbers. The highest exponent power is called the degree, and they're classified by their degrees. Okay, so they're classified by the highest exponent power. So if we were to look at, before we get into this, if we were to look at like 3x cubed minus 9x squared plus 4x minus 4, that is a polynomial. The highest exponent there is 3, so this would be a degree 3 polynomial. And then that would be classified as a cubic. We'll get into like these names in a second, but that would be a cubic. Okay. So let's get into some vocab here. I want you to draw this picture off to the side. I want to draw a couple pictures. Let's start with this. Actually, let's do this. Okay, so if the turning point is higher than any nearby point, it is called a maximum. So like this point right here, that would be a maximum because it's higher than all the points around it. If it's lower than any of the nearby points, that would be called a minimum. So like this point would be the minimum. Okay, now max and mins, relative max, relative min. Okay, relative just means it's not the very highest. I'll go over that more. It's lunch. Okay, but I'll go over that more in class. So maximum and minimum values are called extrema. So whenever it says like find the extrema, that means finding the maximum and minimums. Okay, and then turning points define where the function is increasing and decreasing. I want to go more in depth with that later, and I'll do it with you guys in person, okay? We're going to do this one in class because I want to do this in class when I know everyone is doing it with me. Okay, so let's classify some of these. So this first one, there's no x's there, so that's a degree 0 because we don't have any x's, which means that that is a constant. This one, we just have an x, which has an exponent of 1, so that's a degree 1, which is linear. This next one would be degree 2, because that's the highest exponent there, and that would be quadratic. This next one is 3, which is a cubic, 4, which is a quartic, and 5, which is a quintic. And then after 6, I'm not going to give you that. It'd probably be like sextic or something. I don't know. But yeah, I wouldn't give you over 5. So that's where you got to stop. Now, end behavior. So end behavior determines where the ends of the graph are going. So when you're doing this, I want you to always circle the ends of your graph. Okay, like those are the ends, these are the ends, here's the ends, and there's the ends. Okay, this piece right here, this first one, they are both positive. Both the ends of this graph are going up forever. So they're both positive. If both ends are positive, this right here you have to always write. So I'll explain it right now. This is saying as x goes to negative infinity. So as my x values are getting smaller and smaller, what is my f of x is the output to my x values, so kind of like your y values. what are those y values doing? Well, those y values are getting bigger and bigger, so this is going to be infinity. This part says as x goes to infinity, so I want to do this in a different color. As x goes to infinity, so as we go this way, my f of x, my y values there are also going towards infinity, so that is infinity. Okay, whenever both your ends are positive, you will always get infinity and infinity right there. These two spaces, those two spaces are the only things that will ever change. The rest of it stays the same. Okay, this one, they're both negative, so that means they're both going towards negative infinity. This one, it starts negative and it ends positive, so then the first one's going to be negative, the second one's going to be positive. Because as x goes to negative infinity, f of x is going down, so that's the negative infinity. As x goes to positive infinity, f of x is going up, so that's the positive infinity. This one, start positive and negative, so that's going to be positive infinity and then negative infinity. Okay? So using the leading term, I want you to give the end behavior of each of these graphs. So negative x to the fourth minus x to the second plus 5x minus 1. Actually, let's go back to this slide for a second. So this tells you this is an even power and a positive coefficient. So an example of this graph, and write this on here, would be like 3x to the fourth minus 9x cubed plus 1. So that is an even power, and a positive leading coefficient. This one is an even power and a negative coefficient. So this would be like negative 4x to the sixth minus 5x to the fifth plus 4x. Okay, the highest power there is even, and then the coefficient is negative. This one, it's an odd power and a positive coefficient, so this would be like 4x to the fifth minus 9x plus 1. It's positive, and this is odd. Here it's an odd power, and it's a negative coefficient, so it'd be like negative 7x to the seventh minus 9x cubed plus 4x squared. That's a negative leading coefficient and an odd power. Okay, so then knowing that, we can look at this. So keep that chart handy. This first one, that is negative and the power is even, which means these are both going to be negative. So as x goes to negative infinity, f of x will go to negative infinity. And as x goes to infinity, f of x also goes to negative infinity. Okay, this one is negative and it's odd. And if you look back at that chart, negative and odd means you start positive and end negative. You always end the way that that sign is. So if the sign's negative, your end will always be negative. If it's odd, they're going to be opposites. If it's even, they'll always be the same. So this will be as x goes to negative infinity, f of x goes to infinity. And as x goes to infinity, f of x goes to negative infinity. This one, this is positive and even, which means they are both positive. So then as x goes to negative infinity, f of x goes to infinity. And as x goes to infinity, f of x goes to infinity. This one is positive and odd, so that means you start negative and end positive. So this is going to be as x goes to negative infinity, f of x goes to negative infinity. And then as x goes to infinity, f of x goes to infinity. Here this is positive and odd, so start negative, end positive. As x goes to negative infinity, f of x goes to negative infinity. And as x goes to infinity, f of x goes to infinity. Last one is negative and even, so they're both negative. So as x goes to negative infinity, f of x goes to negative infinity. And as x goes to infinity, f of x goes to negative infinity. Notice this part never changes on any of these. It's just the last two things that stay the same. So this part should never change. That is how I want you to write it. Okay? That is just a mathematical sentence. That part never changes. It's this piece on the end. This is what's changing every time. Based on like positive and negative and even or odd. Okay. Okay, so now we just need to describe the power and coefficient given the shape of a graph. So this one starts positive and ends negative. That means that there's going to be a negative coefficient because it ended negative, and it's an odd power because they're opposite. This one, they're both positive, which means it is a positive coefficient and an even power because they're both going the same way. Okay. Let's do this one. If you have a graphing calculator, pull it out. I don't remember if I did this with a calculator, but put it into your calculator. So we have, first I want to classify this. So this is a quadratic trinomial. Really all I worry about, trinomial means that there's three terms. So quadratic and then trinomial. Okay, if there's more than three, it's called a polynomial. 2 is a binomial, 1 is a monomial. And then let's graph this. So let's use our calculator. Pull out your calculator if you have one, and you should, if you go up to y equals, we're going to do these in class also, but if you go up to y equals and then put this into your y equals, and it will pull up a graph that looks similar to that. Now to graph these, I just want to look at the table. So on your calculator, if you push second graph, it will pull up a table of points, and then you can just graph those points. Okay, graphing anything, you can always just graph points. If you're like, I have no clue how to graph this, put it in your calculator and graph points. Okay, so -3, -2, -2, -5, -1, -6, 0, -5, 1, -2, 2, 3, 3, 10. So there's that. And I just went from -3 to +3. Now domain. Okay, so let's go back. You should have learned domain and range last year, but if you didn't or if you forgot, that's okay. Write this down right here. So domain is your x values. So this is left to right. You always go left to right like you're reading a book. Range is y values. And you always go bottom to top. Okay, it's always least to greatest. Y values, think of that stupid Drake song, like started from the bottom, now you hear. I hate that song. But always start from the bottom and go to the top. Okay, you can't get to the top unless you start somewhere. Domain, x values, range, y values. So here, our domain, well, that's going forever in the left direction and forever in the right direction, so that's -infinity to +infinity. Now the range, that's going to be from -6 to infinity, because the lowest point, if we were to go up this, I didn't mean to do that. So yeah, let's draw this. And if I was to, there has to be a way that I can like move this. My goodness. Maybe not. Sorry, settings. Anyways, sorry. So if we were to go up, so say that you started with like some line right here. And we're just moving up. So we're just going to keep going up and up and up. Well, see, the first place you go where you hit an x value would be right, or a y value would be right there. Okay? And that y value is, oh my goodness, that y value is -6. Okay? And there's a point right there, which means that it is a bracket at -6. So if there is a point, if it is included, wow, I'm so struggling. See, guys, it is fine to struggle. So if it's included, that's when you have the brackets. So if there's actually points. If it's not included, that's when you do the parentheses. So on infinities, it is always a parenthesis. Okay, I'll go over that more tomorrow also. So relative minimum, so the only minimum we have here is an absolute minimum because it's the smallest on the whole graph, but that's going to be at -1, -6. Okay, that's this point right there. There is no maximum because we don't put infinities as maximums, so that's just none. Now increasing and decreasing. So think about climbing a mountain, okay? When you're climbing a mountain, and I'm just going to draw this right here. So say we have a graph that looks like this. And then we have our little person that's walking up the mountain. We can just say that that's Miss Gagan walking up the mountain right there. Well, right here, I am very tired because I'm walking uphill. Okay, and let's say that this is like -2 right there. Well, that means I've been walking uphill, so I've been increasing in my elevation from -infinity clear till I get to -2. If I could walk on graphs, if mountains were anything like graphs. Okay, now let's move Miss Gagan. She is now going to be a green person right here. Now I'm just walking straight. Like, this is fun, this is awesome, because I'm not going uphill or downhill, so my knees aren't mad and my lungs don't want to kill me. This is where it's constant, and that's going to be, let's see, this goes 1, 2, 3 to 3. That's constant from -2 to 3. So there's no incline at all, or decline. But now we have a decline, and I'm just going to pull out my like sled thing and slide down that, because that seems fun. And then I would be decreasing from 3 to infinity. Okay, so you think about it as like you're walking along a graph. If you're walking uphill, you're increasing. If you're walking straight, it's constant. And if you're walking downhill, you're decreasing. Okay, so on this graph, we start walking. If I was to walk along this, this would be downhill right there. So I'd probably like be snowboarding or something. I don't snowboard, that'd be a sight. But I'd be going downhill right there. And so this would be decreasing on this side, clear till I get to this point. Then after that point, I'm increasing, so I would have to be walking up. Increasing and decreasing are always x values. So this is increasing from -1 to infinity, and it's decreasing from -infinity to -1. These are always x values. Okay, and then end behavior, we talked about this. This is both positive, so they're just both going to positive infinity. We are going to save these ones for class because I think this is more of a lesson that we need to go over in class, especially for these parts. So thank you for watching. Hope you're having an amazing day. Goodbye.